All right, let's do it. So, it's surjective. Um, all right, let's see. You said p equals 2. Okay, yeah, let's try that. So m equals, actually just from m equals n, this implies p divides 2fn if and only if p divides f2n. So in particular, f2n always even. Now, moreover, because the function is surjective, if I make like fm plus fn. Oh, you guys are actually doing it though. I was gonna actually just make fm plus fn. All right, whatever. So ffm plus n is equal to a prime power. Then it implies that fm plus fn is also equal to a prime power for all mn, which is pretty strong. It's n to n, so it's okay. Fine. So I don't know. This seems weird to me because I'm not really using the multiplication. This problem doesn't use a multiplication operation. It uses the addition operation. Um. Anyways, can I show the function is injective? Okay. Because I actually really want to invert it. Oh, whatever. Yeah, f takes evens to evens. Like, how do you eventually pin down any? F is surjective at max. I'm just trying to think how you can eventually pin down a number. Like, is this going to be one of those things where you're like, some difference is always divisible by p? Hmm. Hmm. Actually, do we know f of 1 is 1? We should know like f of 1 is 1 because otherwise your yeah, okay, f of 1 is just 1. Cool. Otherwise, because f of n. Great, so I have at least one point I can use. So, what this means is f of n plus 1 is 0 mod p if and only if f of n is minus 1 mod p. That might actually just be an easier thing to think about. Oh, you know one of the things. So already, if I pick a value of, like if I pick a value of n with such that n is divisible by many primes, and f of n is equal to this n, then f of n minus 1 is minus 1 mod n, big N. Fine. V2 of fm equals V2 of m. Do we have V2s? How do I pin down the V2s? VDS of blocking your writing. Oh, that's not great. Alright, let's just say n product of many primes. I don't know. Well, that's not really what I want. Yeah, f of 1 is just 1. Because if it's equal, if something else is equal to 1, then you just die right away. F injective, is that clear? What was wrong with f of... Huh. I'm gonna wipe this section. I don't really like where this is going. So I have this f1 equals 1 thing. I want to sort of have some anchor where I say like, suppose f of like m equals n, where n has many prime factors. Then you kind of get this thing where f of 1 plus f of m minus 1 is, all of these things are divisible. Now, if I pick a different anchor, some anchor of some sort. Oh, this is a lot more slippery than I thought it would be. What until the end with V2s? Wait, okay, I wasn't actually watching the V2 thing. How does that work? Because you only know some stuff about parity, right? I guess it's like, maybe you can get it F2? Oh, okay, fine. So like f of, oh, okay. I think we should push. Sorry, I'm gonna drop the blue stuff. Yeah, like f of 2 is divisible. F of 2 is a power of 2. We'll call it like 2 to the e. And then f of 3 is it gets more confusing. Um, but f of all the powers of 2 are powers of 2. That's actually a lot more concrete. Um, Thanks are really the best for the follow. So f of 4 is divisible by a prime if and only if 2 f of 2 is, and twice f of 2 is equal to, it's more powers. So, okay. Well, we get this big sequence of powers of 2. That's actually really useful, I think, because that way we have a bit of a way to break into the problem. Um, Inject, okay, so I can't keep up with the Twitch chat. Okay, well, someone got injectivity, so that's pretty nice. So injective, if f of x equals f of y, then for any p, take z such that p divides f of z plus x implies p divides f of z plus f of x implies p divides z plus y, and then let's do p impossible. Okay, why is ei equal to I at p squared? Look at smallest n such that v now f of nothing equals v2 of n. I don't. Wait, what did I? So like if f of 2 is equal to. I misspelled c dot. How did that happen? That was not even the same line. Well, f of y minus x. Yeah, so z can vary for p, but the conclusion is p divides f of y minus x, and that one is independent of z. Okay, sorry, Pancho. You're saying, look at n such that v2. Now v2 of f of nothing? What is nothing? Hmm. Why is v2 of f of n at least v2 of n? Okay, I have a bunch of v2 stuff I missed. Um, v2 of f of anything is not equal to v... What? Sorry, I'm so confused. What did I... Eh? Spam m equals n. What? F of odd is odd. Okay. But I really like the powers of 2 because it gives us a like sort of anchor we can use to try to do some values. Like, for example, like, can I get anything out of f of 3 at this point? If f of 3 is... Like, f of 3 has the same prime factors as 1 plus 2 to the e1. But f of 4 is equal to, like... It's supposed to have the same factors of f of 1 plus f of 3, but it's a power of 2. So what's happening is... this is still equal to 1. So if this has... For large E, this is not a power of 3. Right? Like, so this should be divisible by some... no, hang on. I mean, this thing means it's supposed to be a power of 2. So this is equal to, like... Or, sorry, that's in the wrong place. Maybe this doesn't actually imply anything then. So this is equal to 2 to the something minus 1. And it should have the same prime factors as 1 plus 2 to the something. Does that do anything for me? I don't know if that does. It rules out some cases, like... Here, let me think this through. So it's sort of like the radical of 1 plus 2 to the e1 should be equal to the radical of 2 to the e2 minus 1. Like, the set of primes that divide each of them should be the same. I don't know if this is actually really possible. I'm not totally sure. You could have like e1 equals 3 because of that weird Zsigmondy case. Like, it's possible that you have like 1 plus 8 equals 9. And then you would be really sad. Are there any other situations though? Evan, AOIME's tomorrow and I haven't done a single AME. Well, it's 11 p.m. Eastern time, so just chill. I don't know what to tell you. Yeah, it's sort of like, suppose I have some prime, okay? So like some, by Zig, take a, there's a prime factor with order 2 e2, or 2 e1. So that means e2 is divisible by 2 e1. This is assuming it's not equal to 3. This is weird. So if e1 is not equal to 3, then there's e2 is divisible by 2 to the e1. So in particular, I mean, there's some prime factor of 2 to the e1 minus 1. So it has a 2 to the e1 minus 1 dividing it. But that's really bad because that will generate some new prime factors, right? Sorry, I shouldn't write e2 here. I should just write e some like star. It's not e2. I misspoke. We can give a tip off to Ali Ukuro and use an apple. I don't know if I drew the apple well. I don't know how Ali does it. It's like... No, I think I don't even need to... Like, this should give me a proof that f of 2 is either 2 or 8. And actually, I don't think it can be 8. It could be 8 and then f of... But if so, then... f of 3 is a power of 3. Can I rule out the 8 case? I really want to rule out the 8 case, because if I can rule out the 8 case, then by proceeding in the same way, I'll be able to prove that. By proceeding in nearly the same way, I should be able to pin down all the powers of 2. And if I have all the powers of 2 fixed in place, I should be able to blow the problem apart. So, what happens is f of 2 is equal to 8, and f of, so, you know, f of 3 is some power of 3. Can I get a contradiction out of that? Let's erase that stuff I wasn't using, so I can free up some screen real estate. F of 2 is 8. F of 3 is some power of 3. Let f of n equals 2. You get a bunch of pairs that are powers of 2. But I feel like I should be able to kill this case. Why? I really think this thing is so strong that I should be able to get something. Alright, I'm just gonna try this and see what happens, and if nothing works, then I'll go back to what you were trying to do. Okay, well in that case, this still has to be 3, like f of 8 still has to be 3. So this is case 1, this is the bad case. I'll call case bad actually, it's easier. And then case good. In case good, our argument is that f of 2 is equal to 2. So f of 3 is some power of 3. And it's required that 3 to the power all plus 1 is a power of 2. So actually f of 3 is equal to 3, and then you get f of 4. So this is a power of 2, 2 to the e4 plus 1. So at this point, I'm introducing a weird notation, which is these arrows, and by these arrows, I mean that things have the same prime factors. F of 5. Yeah, this is working. This is working. I think we can do this. Well, actually, f of 5 is it has the same prime factors as 5. So again, by massing Zig, which is essentially what I'm doing at this point, I messed something up. No, this is fine. It's just I wrote E4 when I meant E2. So f of 4 equals 4. So the good case is looking really good, and I'll polish this up in a moment once I figure out what's going on. Let me roll out the bad case. In the bad case, if I look at f of 5, it has the same prime factors as f of 4 plus f of 1. So 2 to the e2 plus 1. It also has the same prime factors as 8 plus 3 equals 11. However, 2 to the e2 plus 1 is never divisible by 11. So the bad case dies. So at this point, I've pinned down f of 1, 2, 3, 4. If e2 equals 5, I mean, you get 33, and that has a factor of 3, right? Like, it actually needs to be exactly the same prime factors. So this has been very sloppy because we've been jumping all over the place, and we kind of, keep running into ourselves and doing stuff. But at this point, I'm going to try to write down this argument formally. Do I want to, or actually, let me scout out the rest before, because I think if I keep pushing this, I can solve the problem, and then I'll try to consolidate everything. You need a power of 2 and a power of, you need a power of, you need 2 to the, you just can't do it. Like, you can't get 2 to the something plus 1 to be a power of 11, is what I'm trying to say. Okay, so anyways, at this point I have f of 1, 2, 3, 4 all pinned down. We know f of 1 is 1, f of 2 is 2, f of 3 is 3. Actually, I don't know f of 4 is... Do I know f of 4 is 4? Yes, I do. Yeah. So the prime powers is really what's carrying us. So we still know f of... the powers of 2. I'll make a note of them to the side. But also I know f of 1, 2, 3, 4. And the next power of 2 is 8. So I can pin down f of 5 because I know f of 5... Actually, this becomes dicier because now there's random 3. F of 5 plus 3 is supposed to have the same prime powers as... Well, we know f of 5 is a power of 5. And if I go up to like... f of 5 plus 3... 8. So this is like the Diophantine equation, 2 to the k minus 3 equals 5 to the m, or something like that. And now I can't just nuke everything with Zsigmondy, which is disappointing, because I like nuking things with Zsigmondy. It seems like the problem is that I have this plus 3, but I want to nuke stuff with Zsigmondy. So rather than go after f of 5 next, I'm going to shoot f of 7 down. We can do this because f of 7 is... f of 7 on the one hand is a power of 7 because I know it's 4 plus 3. On the other hand, f of 7 plus 1 ought to be a power of 2. So now we know f of 7 is 7. How did I get f of 4 earlier? I went to 5. Next, let's go after f of 6. So f of 6, on the one hand, f of 6 plus 1 should be a power of 7. So far, I'm still exploiting prime powers a little bit. On the other hand, I think Zsigmondy will kind of... Oh no, this is bad. This is... It works, but barely. This one works because you're solving the Diophantine equation, 2 to the A, 3 to the B, plus 1 is 7 to the C. And that's okay because... That's okay, again, by Zsigmondy, but we're going to run out of luck really soon. Nevertheless, I want to keep pushing these and kind of get a sense of what's going to happen. I think Zig is going to be really big because it's really letting us pin down a lot of values. And then f of 5. How do I get f of 5? Actually, let me write that in green to signal that it was done in that. I'm starting to get a feeling I might be getting baited completely because I'm using so many specific properties of numbers that this might not generalize. For the 5 case, you can take mod 16 with 8. That's probably a better long-term strategy. Yeah, actually that might just be the right way to go. So I have f of 1, 2, 3, 4, 5, 6, 7. Yeah, mod powers of 2, actually, I agree. That I believe that is what I want to do. Let's go up to... So how can I get f of 8? F of 8, I know... So I guess it's doing this induction in powers of 2, where when I want to go to the next step, what do I know now? I know f of 8 is... You know all of these guys are supported on particular primes. So you know for the next several terms that there's only certain prime factors that you like. So how can I try to do something that isn't going to... that's going to generalize later on? I agree, the idea seems like I should be trying to take mods. But I have a lot of mods I can take. The mod 16 doesn't exactly work. But I have so much mod in. It's like f of... when I'm up to here, you know f of 8 plus 1. Like for example, if I want to pin down f of 8, I know f of 8 plus 1 is supported with only on 8, plus 2 is supported on 9. This kind of thing, right? And I really, really want to use Zsigmondy. And I think I can in this case because of... Also, I misspoke. So Zsigmondy will always pin down the power of 2. I will get the 8 here. That part is no issue. The 16 is also fine because it's like... I can tie it to the 15 and then I have Zig power. The problem starts when I have, for example, 15 and 14. I can't use the distance 1. I think I have to go distance 2. On the other hand, maybe for 14 what I can do, but let's look at 10, right? Like, so f of 10 has only 2 and 5 prime factors. Sorry, I want to go 14. F of 14 plus 2 is a power of 2. So, you know, by using the appropriate Zig hammer, yeah, by using Zig, you can get this as 14. And in general, you can do this when the difference is a power of 2. So you can pin down these numbers 14 and 12. Now, if I can do that, can I get the rest? I can get the primes because they're adjacent, but at this point, I'm starting to run out of luck, right? Like I'm really using really specific properties of the numbers, and I need to not do that if I want this to possibly work in general. So what can I do? Like I really like the Zig idea, but it's just there's not enough supply of primes. And somehow I want to automate the... Well, my anchor point probably should be the 16. So let's take an example where it's not so clear what I'm supposed to do. Let's look at like 10, for example, or even 13. No, 13 is too good. I want to look at 10. If we look at 10, it's like f of 10, which only has powers of 2 and 5, plus my anchor point I want to be the 16. I know 6, so this is like 6. It's supposed to be equal to a power of 2. Actually, yeah, is equal to a power of 2. So the problem is there's no analog of Zsigmondy that I can come up with that helps when I have this like 6 like this. Like can 2 to the something minus 6 be... Yeah, this is gonna get ugly real fast. Oh man, like I can definitely do this particular row, but I don't know if I can do other rows after this point. Sad. Does this, can I push this? I really want to push this. It's so weird because, like, for these numbers, I can't really go downwards. Like, if I'm looking at f of 9, for example, I already used up all the information from f of 6 plus f of 3. But in order to continue this induction, I'm kind of... If I want to really get this whole block of power of 2 at once, it's a struggle. So by Zig, this one is 15. Can I use the 15 and 16 together? Like, can I say, like, f of 9 plus... If I take two of these statements together, that's like, for example, f of 9 plus 6 is... f of 9 plus 7 is, like, related to 16. Will that help me? Because... Oh, okay. I think that will work, actually. I think this works now. Because I can get this 15 by Zig, and now I can start pinning two adjacent numbers. So if I look at f of 10, for example, I know f of 10 plus 5 is some related to 15. F of 10 plus 6 has the same prime factors as 16. So f of 10 plus 5 plus 1. Like, the point is, this is supposed to be 2 to the something minus 6. That's really bad, so I'm going to relate it to f of 15 instead. So this is 3 to the star, 5 to the star, some exponents, and this is 2. And now by Zig, this can only occur once. Can I scroll? Yes. 3 to the 15. So I think that will actually solve it. So the reason is I was jumping from powers of 2, but you can do it 2 steps away. My 15 and 16 are tied like this. So I can, for example, get f of 10 by looking at f of 10 plus 5, which I know only has prime factors in 3 and 5, and it's also 2 to the power some power minus 1. And does that work? I'm a little apprehensive. It might be a little delicate. I say delicate because I'm worried. So Zig tells me there's, like, not large solutions. Am I worried there are... No, because I need the star to be at least 4 and equality holds. If the star is less than 4, it's in the earlier block because it's at most 7. So I believe it's a complete solution now. I feel like I'm going to write this up and realize I made some little mistake, but as it stands, I think this basic approach should work. It's funny because I had to fight really hard to get f of 1, 2, 3 down because there's one strange case with Zig. And actually, when I do this approach, I'm going to run into that one strange Zig case again as well, where 2 to the 6 minus 1 is equal to 63. However, I think this should basically work. So, in summary, mass Zig, like, there's so much Zig being used that liberally just yeah. Alright, so for anyone that hasn't gone to bed already, it is almost Amy Day. Any questions on this? I will at some point write this up and post it on AOPS as I have been doing for all the shortlist problems that we solve in this stream. Um, Actually, at some point I should like I should make a spreadsheet where there's like all the problems we do, the stream we did them in, the link to the YouTube video, and the link to the AOPS post. But that sounds like a lot of work. So I might put it off for a long time. Uh, okay, chat has really died down. Is there anyone still here that's not just farming V-Bucks? Yes, nice. Cool. Uh, I should actually check. Is there anything? Does this actually work? Um, Live solving of 50 moves. A You lost a bet with an 8 ball. Oh no. Well, good luck. That narrows it down to like only a couple problems you could be doing. If it's 2007-3, it might be doable. I've been told that it's not actually as hard as I think it is. I can't judge it because I got spoiled. It's 2007 C6. So 2007-3, yes. IMO 3. I am sorry. You are not expected to get the 55 one in contest setting. Is a spiral unit supposed to have super short solutions? To some extent, yeah. All right. This was a fun problem. So much zig. It's like, yeah. I think what happened was I kept trying to do some like really abstract stuff, and then someone pointed out that you could get f of powers of 2 as powers of 2 directly, and then I changed my mind. I was like, just kidding. This problem's actually quite concrete. You can really. I thought it was going to have to be some kind of divisibility size argument, and then it was like, oh wait, I just have a bunch of powers of 2 that I can pin down. Um, and man, have you ever encountered a math contest problem that with infinite time you still can't solve it? Uh, I mean, I haven't spent an infinite amount of time on any contest problem, so shrug. I think there are probably problems that even if I dedicated, um, like, hmm, yeah. I think there's some contest problems I probably couldn't solve no matter how much time I spent reasonably. Um, Obviously, if it's officially infinite, then what you can do is you can write down every possible proof and go through all of them until you can read the proofs, and if they're correct, and you just kind of do some infinite monkey theorem. Uh, you can't test infinite. So to solve a problem means to write down a finite proof, I think. Like you iterate through all possible proofs of a Olympiad problem. Because it's an Olympiad problem, you know that there is a like there is a finite proof because it was proposed to a contest. And you iterate through all proofs. There's countably many of them, so you eventually stumble across the right proof. Um, so yes, given infinite time, I can solve most Olympiad problems by virtue of yeah, exactly. By virtue of simply being able to recognize when I see a correct solution to the problem. That's probably not a very interesting answer to your question, other than maybe you learned a bit of theoretical CS today. But yeah, I'm pretty sure you can easily find contest problems I just can't solve, period. Um, Usomo or Usamu? I think Usamu is much better. I think people should use Usamu. However, I think it is officially Usomo.